Supposed to create some eigenstate of a form like this, which has eigenvalue like h bar upon 2, and we are asked that we need to express our answer as some linear combination of the plus and minus state. What are these plus and minus states? Let us recall. We are eigenstates of a spin z operator, and the answer is also actually given. So, and what is this n? This s spin operator is, we know, are related to Pauli matrices, and this n we can represent as spherical polar coordinates, as we can see from the picture. So let us first write n. So this is z component. Okay, so and z is cos beta, and there will be a component here, cos beta, sin beta. Then this sin beta we can project to xy plane, and this sin beta cos alpha, this will be sin beta sin alpha. So nx is sin beta cos alpha, and y is sin beta sin alpha. Right, so we can just write sin beta cos alpha, sin beta sin alpha, and cos beta. Okay, right. Okay, so when we write s dot n, we are basically doing sx sin beta cos alpha plus sy sin beta sin alpha sz cos beta. In terms of bracket notation, we can write sin beta cos alpha as the x part is plus minus minus plus plus, there is sin beta sin alpha negative I plus cos beta this spin z part. Okay, now this will operate on some state, and in return we should get h bar upon 2, and that is given by something like this. So we need to find this state s dot n. Okay, and what we have been told is that this state is some combination of plus and minus. This is what we have been told. So when this operator will operate on this, what will we get? Okay, so let's try to see that. just go to the different page. Okay, so let us start doing for this first term will get multiplied to all of these terms, and which terms will survive. So the plus, remember that plus minus plus are orthogonal to each other, so this term will not survive. Then again this term will not survive, and this term will not survive. Okay, so how do we write this? Bar upon 2 sin beta cos alpha negative positive plus sin beta sin alpha I, this is positive I plus, okay, there will be, okay, I'll write it in the end. What is, there is cos beta, but it is positive cos beta positive, and all of these terms are multiplied by c plus. Okay, in the next, the parts that will survive are c minus sin beta cos alpha, positive and negative, sign does not change. There is minus I sin beta sin alpha plus and minus, plus and minus, and this cos beta negative, right? Okay, enough. Okay, so I made a mistake here. Okay, these are operators, so yeah. Okay, so when the plus multiplies with plus, the remaining part will be minus. This will be minus, this will be minus, this will be plus. Here it will be so here plus term will survive, the plus term will survive, and minus term will survive. Okay, fine. So okay, so how do we write this? So if we put together only the, let's say, plus terms, or this, so what do we get? There is c plus cos beta plus C minus sine beta e power minus I alpha times plus, and if we look at only the negative states, this ones, so that will be C plus sine beta or I alpha negative minus C minus cos beta negative. And we have demanded that this state will be equal to some parts of C plus plus and C minus minus. Right, so if we compare the coefficients, then the coefficient of plus is C plus is equal to C plus cos beta plus C minus sine beta e power minus alpha. Right, if we compare these coefficients, the C plus here, there is this can be compared entirely with this. Okay, so what do we get? We get C plus 1 minus cos beta equals to C minus sine beta e power minus I alpha. This will give me C plus 1 minus cos beta will give me 2 sine square beta by 2 C minus sine beta e power minus I alpha. Okay, so C plus is equals to C minus sine beta e power minus I alpha 2 sine square by 2, and we know that C plus square plus C minus square is equals to 1. That means C mod square is equals to 1 minus we can just directly plug in the value of C plus mod square here, which will give me C minus mod square sine square beta. Okay, I can just I think it would be better if we keep this as 1 minus cos beta. So that will give us 1 minus cos beta whole square plus whole square is to 1. Minus whole square outside, and it will be sine square beta plus 1 plus minus beta. This will give us 1 plus 1 2 c minus 1 square is equals to minus 2 plus beta is equals to this. Okay, so c minus mod square is 1 minus cos beta times 2 is equals to, again just write it as 1 minus cos beta whole square is equals to 1 by 2 1 minus is 2 sin square by 2 whole square is equals to and from this we get plus c plus s cos beta by 2. We are just assuming c plus c minus are real. So based on this, what are we getting? Eigenstate looks like this: cos beta by 2 is okay plus sin beta by 2. But well, we know that this is not true, because in quantum mechanics amplitudes, probability amplitudes in general are complex. So we say that c minus is equals to sin beta by 2. Let's say there is e power I theta 1, and c plus is cos beta by 2 and theta 2. And the relation that we had established previously, like this one, sorry about this mess, but the relation is that c plus is equals to c minus sin beta e power minus I alpha divided by minus cos beta. So if I write c minus as sin beta by 2 e power I theta 1 sin beta minus I alpha 1 minus cos beta, it is 2 sin square by 2. This will be so in the nominator I have expanded this part, sin beta, 2 sin beta by 2 cos theta by 2. Okay, so this gives us c plus cos theta by 2 e power I 1 plus alpha. So let's look at C plus. Okay, we are getting something. So if I say that theta 1 minus alpha is equals to some theta 2, then we get C plus is equals to cos theta by 2 e by 2, which we have already done. So for simplicity, if I say that theta 2 is equals to 0, then C plus is cos theta by 2 and C minus will be sine beta 2 or alpha. So finally, what will we have? And C plus is our cos theta by 2 alpha. So this is what was asked. Okay. Yeah.